In this chapter on exponential and logarithmic functions and equations, we're going to be looking at two different types of exponential equations. The first type we're going to label nice exponential equations. Nice exponential equations essentially mean that we can rewrite both sides of the equation with the same base and solve a resulting equation from the exponents. The other type of exponential equations that are not nice we'll cover in the last section in this chapter because we need some more tools before we can solve it. And those would be if the two sides of the equation cannot be written as the same base. So in this first set of exponential equations, solving the nice ones, each side of the equation must have the same base. If two sides of the equation do not have the same base, we're going to rewrite the sides as the power of a common base. Then we simplify our exponents using the rules of exponents that we've talked about previously, particularly in the rational exponent section. We'll set the exponents equal to each other because if we have the same bases, then our exponents have to be the same. So this is coming from if I have a to the m equals a to the n, and the a's are representing the exact same number, then m and n have to be equal to make this equation true. So we're using this property to set the exponents equal to each other. And then we'll solve and check. Let's walk through a few examples together, starting out with 2 to the power x equals 64. We want to be able to write both sides to the same base, so both sides having the same base. I can't make 2 any smaller than it already is. So let's play around with 64. I know that 64 is 8 squared, and I also know that 8 is 2 to the third. So I'm going to take this 2 exponent and bring it down. So 64 is 8 squared, and I'm just rewriting 8 as 2 to the third. Now, do you remember about exponent rules, what we need to do when we have an exponent raised to an exponent? That's right, we multiply. We multiply the exponents together. So 3 times 2 would be 6. 2 to the 6th power is 64. We can check that, pull up our calculator. 2 to the 6th power gives me 64. Don't be afraid to use your calculators. It's perfectly acceptable to check your answer here. If we didn't recognize 8 squared at first, and we recognized 4 to the third, that's actually okay too. Watch what happens. 64 is 4 to the third. 4 is 2 squared. And then check it out. If we multiply exponents together, 2 times 3 is still 6. So 64 is 2 to the 6th power. On the left, we have 2 to the x power. So what does x have to be? Well, since I have 2 and 2 for the bases, and they are the same, we would equate our exponents. And so x equals 6. And that would be our answer. You try b on your own. 5 to the power x equals 125. See if you could get the answer, pause the video, work it out on your own, and when you resume, I'll talk you through it. 5 to the power x equals 125. We need to figure out if we can write 125 as a base 5 to what power. We could do this 2 different ways. Let's start with 5. So I can't break 5 apart any smaller. So let's multiply 5 by itself and talk about how many times we have to multiply 5 to get 125. So 5 times 5 would get us 25. There are 2 5s. Multiply by 5 again, we get 125. We multiplied by 3 5s, so 125 would be 5 to the third. And then 5 to the power x equals 5 to the third. The bases are the same, so we just need to equate the exponents, and x equals 3. Let's look at some that are a little bit more complicated. Now we don't just have one variable in an exponent, we have a linear expression, 2x minus 1. 2 to the power 2x minus 1 equals 32. We need to write them as the same base. 2 is as small as I can go, so my goal is to get 32 as 2 to a power. So I have to figure out what that power is. Another strategy that we can use to do that is start at 32 and divide by 2's and see how many times we divide by 2 to get our answer. So here's 1, 2, 3, 4, 5 gets us all the way down to 1. So I divided by 2 5 times. 2 to the 5th is 32. Let's check it. 2 to the 5th power, 32. Awesome. So now I have this same base, 2's. I make the exponents equal to each other. 2x minus 1 equals 5. Now we have to do a little bit more work. I want to solve for x. I want to know what x is. Now we solve this linear equation. Undo the operations being done on x. We'll start with a subtraction. Divide by 2. We get x equals 3. This one's not bad to check. 2 to the power 2 times 3 minus 1. 2 to the power 6 minus 1 gives us 2 to the 5th, which is 32. It works out. Looking at 32 to the power x equals 8. 32 is not a perfect power of 8 because 8 squared is 64. That's too big. Neither of them are perfect powers of 4, but they are both perfect powers of 2. 32 we just found out in the previous problem was 2 to the 5th. So I'm going to drop that x onto the parentheses. 2 to the 5th to the x power. And then 8, we saw above in part A, 8 is 2 to the 3rd. Now, 2 to the 5th to the x power, we multiply exponents. 2 to the 5x equals 2 to the 3rd. My bases are the same, so my exponents are equal. 5x equals 3, divide by 5, and we get x equals 3/5. Let's check it. X is 3/5, so we're going to put 32 to the 3/5. Does that equal 8? So 3/5 exponent, remember what that means? 5th root of 32 to the 3rd power. So the denominator is the root, the numerator is a regular exponent, and we want to know, does that equal 8? The 5th root of 32 is 2. We can do that one in our calculator as well. It's not as easy because I don't have an nth root in my calculator. I only have a square root, and I don't get to use that function. But I could do 32 to the 1/5 power, and I get 2. And then I raise that to the 3rd power, and I get 8. It indeed works. You could also do just the first step, 32 to the power 3 divided by 5, and see that it equals 8. Most of the calculators are pretty nice in that you can put in rational exponents and they work out. I'm going to leave part E for you to try on your own, but I will give you the answer to it. In part E, x equals 1/4. Try out part E on your own. Check to see if you get x equals 1/4. If you don't, pop on over to the OneNote link and see the steps that I used. See if you can find your mistake and correct it. Parts F and G are pretty similar to each other. Again, I'd like for you to try these on your own, get some practice in, and see if you can come up with the answers. And I'll give you the answers here. For F, the answer is -2. And for G, the answer is -1/2. See if you can come up with those answers on your own. Let's take a look at part H to finish out this part of the lesson. 3 to the power x equals the 5th root of 1/9. There are actually two main possible ways that we could solve this equation. Let's do it one way, and then I'll show you the second way and see how they're connected. So in the first way, we'll keep the two sides separate with the goal of writing the 5th root of 1/9 as a power of 3. So 1/9 5th root would be 1/5 for the exponent. 9 is 3 squared. Since I've got 1/3 squared, I can write that as a -2 exponent. And then an exponent raised to an exponent like this is, I can multiply them. -2 times 1/5 would be -2/5. And I have 3 to the x power equals 3 to the -2/5. So x equals -2/5. So this is one way. An alternative way, which is still equally as valid, because this is an equation, I could start out and use what we've already learned with with radical equations and get rid of the radical that's on the right. So we could raise both sides. We could raise both sides to the fifth power here. And in doing that, the fifth power with the fifth exponent gives me 1/9 on the right. And then 3 to the power x to the power 5 would be 3 to the power 5x on the left. And then 1/9 is 3 squared on the denominator. 1 over means I can change that exponent to be negative. 3 to the negative 2 power, 3 to the 5x. And now I have the same base. I equate the exponents. 5x equals negative 2. Get x by itself. Divide by 5. X equals negative 2/5. I get the same answer. Still using properties that we've already talked about with radical equations, or just sticking with the two sides remaining separate and solving that way.